Okay, so for 5.4 day 2, we're still doing exponential, but now we're going to talk about the integral of e to the x. So do you guys remember what's the derivative of e to the x? E to the x, okay, right? It didn't change. So when we're integrating, it's the same thing. It's just backwards. So the antiderivative or integral of e to the x is e to the x. The only difference is we need to go ahead and put plus c since we're integrating. And so if that x changes to something else, like say u, it's just e to the u plus c. And this u is really hinting that we need to use u substitution. Okay, so we're going to be using u substitution and the fact that derivative, antiderivative of e to the u is still just e to the u. So on one hand, this is actually easier than what we were doing last week, I think. Okay, so see how that says e to the u? That's also hinting at, hey, when you have e to a power that's not just x, let that be the u. So on number 1, we need to let the u be that power, negative x squared. Then what would du equal? Yeah, negative 2x dx. And that negative 2, we've been doing this for a while now, we divide over to the other side. So negative 1/2 goes to the front. There's another number that's going to go to the front. 3. Okay? So then we got to think, okay, did I take care of everything? The 3 I took care of. Okay? The e to the u I took care of. But watch this. See this x and this dx? They're right here. So they get replaced with the negative 1/2 and the du. I've already written the negative 1/2. So I get to just write the du. So negative 1/2 times 3, I'm going to go ahead and rewrite that as negative 3/2. And we just went over this. What's the antiderivative of e to the u? Just e to the u. So then my final answer needs to not be in terms of u. It needs to be in terms of x. So I replace u with negative x squared, and that's your answer. How could I check this? Take the derivative. Yeah, take the derivative. Okay, so the way we would derive this is we'd say, okay, let's just write negative 3/2 times e. Okay, and remember when you take derivative of e to some power, you just rewrite it, and then you go times the derivative of that power, which would be negative 2x. So I've kind of covered this up, but my question is this the same as this? Yeah. So the negative 3/2 times 2, you know, the negative and the 2, those cancel. And the x is at the end instead of at the beginning, but it's the same thing. And so that's how you know you did it right. Sometimes when you check your answers in the back of the book, the answer may look a little bit differently because it may be simplified or rewritten. But so that's why I really want to encourage you to check your work by taking derivative. And that's obviously the only thing you're going to be able to do on a quiz or a test. Okay, so let's look at problem 2. All right, so in thinking about what we did in problem 1, what are we going to let u equal in problem 2? 2 over x. Is there another way I can write that?
2x to the negative first.
Yeah, 2x to the negative 1. And that's going to be helpful because we got to do du next. And I don't want to have to use quotient rule like to do just du. All right, so then du, remember derivatives. I know it's hard to go back and forth between derivatives and integrals. It gets easier the longer you do it. So negative 1 times 2, negative 2. Remember, subtract 1 from the power when we're deriving dx. Okay, this negative 2 in front, just like every other time. We move that thing to the front of the integral. And in this case, there's no other number to move out. Okay, so I had e to the 2 over x power. That becomes e to the u. And now we got to think, there's this x squared in the denominator.
It's taken care of.
Where is it taken care of?
X to the negative second power.
Yeah, those are the exact same thing. X squared in the denominator is x to the negative 2. And dx, of course, is in both places. So I take out those two things and I replace it with du and negative 1/2, but I've already written that. Okay, so now we integrate, which is easy. E's for easy, just kidding, but this is easy. You don't really have, and if you get confused between derivatives and integrals, it's okay. It goes the same way. Okay, so then my final answer is negative 1/2 e to the power of not u, but 2x to the negative 1. It would be totally fine here if you wanted to write that as 2 over x, like how it was in the original problem. That's fine. It's also fine the way I've written it here. And we could check this by taking the derivative. I'm not going to spend time right now doing that. Okay. All right, let's look at number 3. Okay, how's number 3 different than the two we just worked? It has bounds, and it doesn't have a weird power. It's just e to the x. Okay, so what are we going to let u equal? Let me just tell you, you are never going to do this. Never. U and x, that doesn't help you. It's just a different letter. Okay, so any ideas on what we could let u equal?
1 plus e to the x.
Yeah, y'all are looking at the denominator thinking about what we did last week.
Yeah.
And if we pick the wrong u, then you figure it out pretty quick. Okay, so du. Well, remember, derivative of 1 is 0. Derivative of e to the x is just e to the x. And then dx. And so we'll get to the bounds here in just a second. But look what happens here. Your u is in the denominator, so that becomes 1 over u. The e to the x, that's up here, that's taken care of right here. It's a total matchup. E to the x and dx get taken out, and they get replaced with du. Okay, now let's talk about the bounds. So the top bound was 1. Okay, we got to do 1 plus e to the 1. 1 is an x value. What is the u value then? Some people don't like saying this because they feel like it's wrong.
Would it be 2? Because e to the first power is... No, it's 0. So it's going to be 1.
That's going to come up in just a
Yeah.
minute. So we're just going to write 1 plus e. I know that looks strange,
Oh, no way.
but that's okay. All right, now 0, 1 plus e to the 0, this is 1. So that 0 turns into a 2.
Wait,
E to the 0 is 1.
no.
The same way natural log of 1 is 0, e to the 0 is 1.
Do we have a list of different e values, the common ones?
This is the only one you know. Like e to the 2 is just e squared. E to the 5 is e to the 5th. E to the 0 is the only one that simplifies out.
Okay.
Okay, so then let's go ahead and take the antiderivative. What's the antiderivative or integral of 1 over u? Natural log of u. Okay, so now we integrated, now we plug in our bounds. Do I need to replace u with 1 plus e to the x?
No, because we bounds.
Okay, so I have the new bounds. I don't need to go back to x. In fact, if you do replace the u with 1 plus e to the x, then you've got to use your original numbers, and why did we spend time finding the new numbers if we were going to do that? Okay, so then this becomes natural log of 1 plus e minus natural log of 2. Now I went ahead and left the absolute value bars in here. Do I need them? Like 1 plus e, isn't that a positive number? Okay, so I could put parentheses there. It's totally fine if you leave it as absolute value. But I just want you to know, like, if you had a multiple choice, I didn't want you to think this was wrong. 2, that's also a positive number. Okay, that's great. Probably, though, if this was multiple choice, they would even condense it into a single log. How would you do that?
You'd put that as a fraction.
Yep, 1 plus e over 2. Okay, but this is I don't expect you guys to do that on a free response. Okay. Alright, last problem we're going to do together. Okay. I want you, on your own, just to write down what you think u should equal on this. Okay. Anybody feel brave? Feel confident? What did you let u equal?
I said u is e to the x.
Okay, e to the x.
You can write it down as a puzzle.
No, that
We
would
can do that.
you never know. Huh?
I can do.
You can't let u be just, sorry. You can't let u be
Just be
just x. But u could be e to the x. Did anybody choose something else, though? I'm not saying this is wrong. I'm really not.
I-
What a common thing here is people want to let. Go ahead. Sorry, I keep cutting you off. What do
Well,
you?
I chose cosine e to the x, but I know it's wrong because then it becomes negative sign and.
Right. Okay. So this wasn't a bad idea. I mean, a lot of people try this, and then you figured it out right away because.
The
I think
derivative
my pen's
is not
dying.
in the equation.
No.
Or no.
Okay. I think it's okay. All right. So that would become negative sine e to the x, and then you're still gonna have another e to the x. All right. But the problem here is there's no negative sign. So this is what I'm saying. It's okay if you pick the wrong u. You figure it out really fast. So Kieran was right. It is e to the x. And I know some of the rest of you did that as well. So u can just be e to the x. It's just not going to be just plain x. Okay, so let's see what we got here. Okay, well first let's do du. Du then would be e to the x dx. And that's great because I see an e to the x and a dx right there in the problem. Okay, so I have cosine u du. Don't forget the cosine part. All right, now what does the top of bound turn into? What's e to the 0? 1. We just talked about that. All right, what does the lower bound, negative 1, turn into? Yeah, e to the negative 1, or you could call that 1 over e. They mean the same thing. It doesn't really matter which one you choose because they're both equal. Okay, what's the antiderivative of cosine u? Sine. Are we confident that it's positive sign? I'm going to show y'all something that I learned from another teacher here in a minute. It is positive sign, by the way. So then we plug in our bounds, sine of 1 minus sine of e to the negative 1. That's your answer. You need a calculator to go any further. Okay, so here's something that a teacher told me, and I'd heard something similar to this, but it never really taught with it because I didn't like it. But what she told me was kind of a variation on it, and I really like it. So here's what I want you to do. Imagine it's summertime, it's a really hot day, and I give you a snow cone. I say, here's the snow cone, just because I like you and you're my friend. And I say, I'm taking that snow cone back and I'm eating it because I'm a jerk. Okay, so I take the snow cone away. You guys see where I'm going with this? I give you a snow cone, and I go, nope, my snow cone, I take it back. That's why there's negatives there. This is what this means. Okay, if you are, my pen is dying, but maybe I can explain it without it. If you are taking derivative, this is the order that you're going to go in. If derivative of sine is cosine. Derivative of cosine, negative sine, derivative of negative sine, negative cosine, derivative of negative cosine, back up to positive sine. Okay? So if we go down each time for derivatives, then what do you think we'd do for integrals?
We go up.
We would go up. So if you're integrating cosine, that's sine. If you're integrating sine, you go back all the way to the bottom, that's negative cosine. For some of you, you don't need this. It's best for you just to stick with how you did it before. But if you're always getting mixed up between the positives and negatives, this may be a good thing for you to do. I don't want to give you too many of these because they kind of lose meaning or you forget what does it mean. You know, a trick doesn't help you if you can't remember it. So I try to limit these to when I think it's really going to help.